Draw a labeled ray diagram of compound microscope when final image forms at the least distance of distinct vision. This compound microscope where we are going to use. It is used for observing highly magnified image of teeny objects. Normal microscope, we can see the objects in some particular zoom. But the compound microscope, for very teeny objects, we can see in a magnified image format, we can use the compound microscope. Okay, here when to construct means we'll see the how it works now. Okay, this is the ray diagram of the compound microscope. It consists of two different lens. Okay, this is the object lens, this is the objective lens, and this is the eyepiece lens. This second one is the eyepiece lens. And these two lenses are in a coaxial. That means on the same axis these two lenses are placed. Here the object is there. Assume this is the object. AB is the object. Okay. From the A height it will be reflected through this point, and it is when it is moving in this particular for this lens up to here. And from the bottom of this one it will move in this direction, and from this point it will move up to here. Okay, like this it will be move, and where these 2 points are coincide, this is the one dimension, that is one lens we can see here. That means some zoom we can see, that is we noted as A dash and P dash. From this one we can, it is reflected further like in this direction, and where it is coincide in this way, so this is noted as A double dash and B double dash. Okay, this is, and these two lengths are fixed over a one tube. That distance may be the L or D. Here it is noted as D. That means from the eyepiece lens to the zooming object where I can see, this distance we noted as a D, and it is not necessary always it is behind the objective. Sometimes it may come here also. In this way the compound microscope will be work, my dears. Come on to the second part. Why is its objective of short focal length and of short aperture compared to its eyepiece? Okay. To have a high magnifying power and high resolution, the focal length of the object and its aperture should be short. Focal length of eyepiece is comparatively greater than the objective, so that image formed by objective lens may form within the focal length of eyepiece, and the final magnified image may be formed. Aperture in short for higher resolution, and it is given by m is equal to m naught into me, that is equal to L by f naught into 1 plus d by fe. The focal length of the objective is 4 cm, while that of eyepiece is 10 cm. The object is placed at a distance of 6 cm from the objective lens. We need to calculate first one. Calculate the magnifying power of the compound microscope if its final image is formed at the near point. Second one. Also calculate the length of the compound microscope. Okay. First we need to find the power of compound microscope, this magnifying power of compound microscope. Then we need to find here, that is, we know that here a U naught is equal to U naught is equal to minus 6 cm for object length. For object length, 1 upon F naught is equal to 1 upon U V naught minus 1 upon U naught. Then 1 upon V naught is equal to 1 upon S naught plus 1 upon U naught. by substituting the values, that is 1 by 4 plus 1 upon minus 6, we will get the answer V naught is equal to 12 centimeter. Then, since for eyepiece, VE is equal to minus T, that is equal to minus 25 centimeter. Then 1 by U naught is equal to 1 by VE minus 1 by FE, that is equal to 1 by minus 25 minus 1 by 10. Then UE is equal to minus 7.14 centimeter. Then first one they are asking here, magnifying power of the copper microscope, that is M is equal to, first point they are asking magnifying power component, then M is equal to V naught divided by U naught times 1 plus T divided by FE is, then we get set of the values. M is equal to 12 divided by 6 times 1 plus 25 divided by 10. We get the answer M is equal to 7. Then second one they are asking here, length of the copper microscope, that is L is equal to V naught plus mod of UE, that is equal to 12 plus of minus 7.14, that is mod, that is equal to 7.14. Then the value becomes 19.14 centimeter. With the help of a labeled ray diagram, explain the construction and working of a Cassegrain reflecting telescope. Okay, what will the Cassegrain reflecting telescope will see now? Okay, there are two different types of reflecting telescope, that is a Newtonian telescope and a Cassegrain reflecting telescope. The difference is, in the Newtonian telescope, here the secondary mirror, it is the plane mirror, but here it is a convex mirror. Okay, and the objective mirror, it is same as the concave mirror. Okay, when the light rays is passing in this direction and it will be reflecting over the concave mirror and it will be reflecting to the secondary mirror, then the number of light rays is passing and everything, it will be reflecting like this, and in this direction also it will go and it will be reflecting like this. Finally it will reflect for our eyepiece in the magnified image. In this way the Cassegrain reflecting telescope will be working. Okay, then part B, an army amateur astronomer wishes to estimate roughly the size of the sun using his crude telescope consisting of an objective lens of focal length 200 centimeter and an eyepiece of focal length 10 centimeter. By adjusting the distance of the eyepiece from the objective, he obtains an image of the sun on a screen 40 centimeter behind the eyepiece. The diameter of the sun's image is measured to be 6 centimeter. Estimate the sun size given that the average Earth-Sun distance is 1.5 into 10 to the power of 11 m here. Okay, then for the eyepiece it is 1 upon, that is B, 1 upon VE minus 1 upon UE is equal to 1 upon FE. Or we can write this one as 1 upon UE is equal to 1 upon VE minus 1 upon FE, which is equal to 1 upon 40 minus 1 upon 10. Then UE is equal to 40 by 3 centimeter. Magnification produced by eyepiece is, that is ME that is equal to VE divided by mod of UE, which is equal to 40 divided by 40 by 3. We'll get the answer 3. And diameter of the image formed by the objective is D is equal to 6 divided by 3, that is equal to 2 centimeter. D be the diameter of the sun, then the angle subtended by it on the objective will be alpha, that is equal to D divided by 1.5 into 10 to the power of 11 radians. Then angle subtended by the image at the objective is equal to the angle subtended by the sun. Therefore, alpha is equal to size of the image divided by f naught, that is equal to 2 by 200 is equal to 1 by 100 radians. Therefore, D divided by 1.5 into 10 to the power of 11, that is equal to 1 by 100, or D is equal to 1.5 into 10 to the power of 9n.